Okay, so when it comes to decimal, and I do this specifically with decimals, but you can do it with any large numbers, okay? So I have 23 and 45 hundredths, and then 72 and 1/10. And these are being multiplied together, okay? So multiplication, there's a methodology called the lattice method. And I've seen this, the Japanese are doing this as crossing lines, okay? We've been doing it for a lot longer, and it's the lattice method. It's essentially, if you pull it apart, it's all about counting things in specific place values, okay? So this and that are going to come up with the exact same value in the end. But our process, using this, because if I do this and I start shifting over and I do my traditional method, it's going to be really long, and it's going to have a lot of things that I have to keep track and keep in order, okay? This is going to do a lot of the exact same work, but notice it's already got order to it, okay? So I set this one up for this problem. The first number has 4 digits, so my number of number of columns is 4, right? 1 for each place value there. The decimal is not a place value. It does not get its own place value, okay? Then I have as many rows as the second number, okay? How I put these in is this one goes straight over, 2, 3. The decimal goes on the line, okay? And we'll see how that plays out in a minute. Because again, it's not a place value. It's something that we use to help line up place values, but the decimal itself is not a place value. Now, my second number goes largest to smallest as we move down. 72.1, right? And the point goes on the line as well, okay? So I've got decimals on these two lines, and we'll see how that plays out in the end. Then this is pretty much a traditional multiplication chart. These two, the column and the row, meet up at this box, and 2 times 7 is 14, okay? So there's a tens part and a ones part. Now, because all of these are single-digit multiplication, I'm never going to get a 3-digit answer, okay? The biggest I'd ever get is 9 times 9, and that's going to be 81. So all of these only need to have 2 parts to it. Now, what if I don't have a tens part to it, which will happen down here? So as I do the multiplication, 3 times 7, 21. 4 times 7 is 28, okay? Here, 2 times 2 is just 4. Where do I put the 4? Well, there's 0 tens and 4 ones in that, okay? 0 tens and 6 ones. 8, 10, 1, and then 0 in the ones, okay? Now, each of these, because of the diagonals are might be a little bit hard to track some of the place value aspect. So just look at it one block at a time, okay? Don't think about all the other ones. That's the beauty of it, is that it's doing that kind of work for us. It's lining up all of our place values for us, okay? 2 times 1, 0, 2, 0, 3, 0, 4, 0, 5, right? So I did all of the multiplication for each of these columns and rows as they met there, okay? And the nice thing is, with this lattice method is what it's called, I only have to know my single-digit multiplication. So that helps me as a student be much more confident in even trying this, because it's not requiring me to start memorizing multi-digit multiplication tables, okay? So now, after I've done all of these, the diagonals come into play. I look and I start on the far side, the right side, adding up my smallest place values. 5, 0 plus 0 plus 4 is 4, okay? Adding in here. Now this is where it's going to get a little bit more complicated, because I've got 5 plus 1, which is 6, plus 8, which is 14, plus 3, which is 17. So the 7 goes here, and just like place value addition, I'm going to carry over into the next column, okay? So now as I go to add this column, I already have 1 plus 3 is 4, plus 8 is 12, 6 is 18, 2 is 20. That means I put the 0 here and carry the 2 into the next column. 5 plus 4 is 9, 6, and 1, okay? So I have my answer here, okay? It's written from here going down and around, okay? This is when our decimal placement comes into play. Over here, right, I'd be like, oh, there's 2 places and there's 1 place, and so I count over 3 places, okay? Here, in the lattice, it already places the decimal for me. Because remember, it's on a line. So I trace that line down, and I trace this line over. Where they meet is a new line at the diagonal, and I place the decimal according to that. Notice it's 3 places in. It does it automatically for us, which is just so cool, okay? So my final answer is 1,690.745. Okay? So that, if I were to do that, longhand, pop it in your calculator, you're going to get the exact same thing, as long as I did all of my actual small step math correctly. So this is the lattice method. How to plug it in, how to use the decimal to help you get it out. Final answer, really nice, really simple, good to use. Don't be afraid of it, and don't be afraid to teach it, okay? Because it can help somebody who's not real comfortable with decimal multiplication or just big number multiplication.